going to start over here. We call that time 0. And we're going to start at 0 feet. We're using feet on this. We don't have to convert any numbers that are nice to us here. At some time 1, let's call that position 1 and time 1. The rocket engine shuts down, and so we enter into a new phase here. So in this phase here, they told us the acceleration is 41 feet per second squared. All right. It runs along. So here's at time 0, we're at 0 seconds. Time 1, we're at we don't know. And then it moves at a constant velocity for time 2. So, all right. So Vx naught is what? What's our initial velocity? It's 0 feet per second. Vx1, do we know that? We don't know what that is, all right? But we know when we get over to this later point in time, let's call this x2 and t2, all right? We know that the velocity, the acceleration here is 0, all right? So we know the velocity here is still vx1, all right? So we've got a constant velocity, all right? What other numbers do we know in here? The total time, and where am I going to put that on here? Which variable up here represents total time? So T2 equals how much? 90 seconds. And what else do we know? Alright, so this is 19,100 feet. Okay. And, alright. So assume the total distance traveled and the total time is 90 seconds. All right, and they asked us to find after time t1.
I think I see 1 second. Do we use the first and second point?
Yeah, you gotta be. Yeah, so from here to here is 90 seconds. Alright. We don't know, we want to figure out what this is. And in fact, that's part A. Alright. Time 2 is this difference in time right here. Alright. So this is also part A. Alright. So they don't actually want, what I'm calling here is time 2 is 90 seconds. They want T2 minus T1. So this is T2 minus T1 they want, and they want T1. That's from part A. Okay? And then find the velocity. And that's going to be this velocity. This is for part. That's for part B. Okay? Alright, and we got to break this problem into 2 pieces because we'll call this phase 1, we're accelerating, and phase 2, we're coasting. Alright, so we're going to have to break down our problem into 2 pieces for our equations. Initial position, initial velocity, and our acceleration are what? Our initial position is 0 feet. Our initial velocity is 0 feet per second. And our acceleration is 41, positive 41 feet per second squared. Alright. At time 1, we end up starting phase 2. So we know that our I'm just going to call these, instead of zeros, I'm going to call this x1, vx1, and I'm going to call this, let's call this ax1. I'll call this one over here a0. And we've got our position is unknown. We don't know what this is yet. Okay. Our velocity is unknown. That's what we want to find. This is part B. All right. And we know that that's 0. All right. And we know at time 2, we know something though. At time 2, at some later point in time, we know that our x2 position is our 19,100 feet, and we know that our total time equals 90 seconds. All right. So let's go ahead and we'll set up some equations based on that. All right, and we've got some unknowns here. And this is a little bit of a messy problem. So we don't have, if it was like one phase or the other, you could just it'd be very easy to find one set of things. But now we got to use phase 1 and phase 2 together to look at the overall look at the situation. Let's set up this good from t0 equals 0 seconds to t1 equals whatever, and that's what we need to do. Phase 2. What do we know? Phase 2 is constant velocity. So your acceleration in phase 2 is 0. Alright. What equations should you consider when you're doing that? For phase 1, we have constant acceleration. So we get to use our equations. Alright, so we've got our constant acceleration. Phase 2 is constant acceleration too. It's just a zero, so it's a really simple case of constant acceleration. What you're going to see is it turns out you don't really have to use these complex formula when you have zero acceleration. Everything's zero. All your acceleration is zero out in equations 5 through 8, and it turns out that to simplifying other equations you recognize. So you look at this. Ax2 is 0. Alright, so this whole term is gone, which just tells me that vx1 equals vx1. Alright, our velocity x1 doesn't change, is what that tells us, right? Look what happens over this side. That's 0. Alright, for this side of the equation. And what I get is, I get my future position, alright, equals my starting velocity at time 1 times my time plus my starting position. If you look at this, I've got distance equals speed times time. Alright, so once I have no acceleration, it's easier in a lot of cases to use your good old distance equals speed times time. Let's just check off and see what we know first. Alright, do we know x1? Do we know what x1 is? Alright, so we don't know what that is. Do we know AX? Do we know T1? No. Do we know VX0? We know what VX0 is. It's 0. It's going to knock out. We don't know what that is. Do we know what X0 is? Yeah. Yes, we do. Alright. Do we know what VX1 is? Don't know what that is, right? Do we know what AX1 is? Yes. Do we know what the time is? Do we know what VX0 is? That's 0, right? Starts at 0. So our unknowns here, let me just underline the unknowns. We don't know x1, we don't know t1, right? We don't know vx1, all right? But once again, we don't know t1. So we've got 3 unknowns. So we've got 3 different unknowns. We've got 2 unknowns here. We don't know x1, we don't know t1, and we don't know vx1. But we've only got how many equations? 3 unknowns. We've got 2 equations. That's not a good situation. If we look at the unknowns we have here, we don't know this, right? Actually we do know this. This is unknown. Alright? We know that's 90,000 feet or whatever. We don't know this one, but this comes from up above, alright? So that's an unknown from up above. We don't know our velocity, but that's from up above. We don't know this. We do know this final time, so we do know that. We do know that, but this is going to zero out in any case. All right. So we have one more equation, but unfortunately, it also introduced a 4th unknown. So now we have we've got 1, 2, 3 equations, and unfortunately, we just added a 4th unknown, x2. All right. No, it's not x2. We know t2. We don't. We don't know how long the second time frame is. And remember, this T2 is going to be, we're resetting our clock starting at 0. So we've got to be careful here. This T2 is just your change in time from whatever your first phase I deduct that to your second thing. So we got to be careful how we interpret that T2. That T2 is not 90 seconds. All right. So I don't know. Maybe we should call this T2 prime or something, because that's not 90 seconds. That's going to be a different time. So we're presuming we're starting from 0 here again. We're reset our stopwatch. All right. So maybe we should call this. Well, this is what the book called it actually. Let's call this time from here T2, and we're going to call this our T3 is 90 seconds, our total time. And we know that T3 is given to us 90 seconds, and we know that that equals what? 90 seconds equals what? The sum of what? T1 plus T2. All right. That gives us another equation with our two unknowns in it. All right. This equation doesn't do anything for us. All right. So we have how many unknowns? We don't know x1, we don't know t1, we don't know vx1. All right. We also don't know this thing over here we're calling t2. That's four unknowns. How many equations do we have? We've got one equation, two equations, we've got three equations, we've got four equations right here. Four equations, four unknowns. X1 equals, let's see, we've got half of 41. Of course, it's an odd number to us. So it's going to be 20.5 times t1 squared plus, and our initial, we know our initial velocity is 0, so the center term is going to cancel out. And we know our initial velocity is 0. Our initial position is 0, so that's fine. All right, so that's a nice simple equation. All right. In equation 6 over here, we know that vx1 equals our 41 times time plus our initial velocity is 0. So that's perfect. All right. 19,100 equals, this first term is 0. The second term is vx1 times this time, which is this guy right over here. All right. Plus our initial position, which was, we don't know what that is. That's what we're going to call that x1. All right. All right. So we've got four equations, and then let's just list out the unknowns. All right. Those are our four unknowns. Those are everything that they asked us to solve for. And we have four equations to solve them. Let's call this equation 1, equation 2, equation 3, equation 4. Let's start with this one. 90 equals T1 plus T2. That's really easy to work with. So what I can actually do is, if I solve this for T2, I can substitute out for T1 there. And that knocks out T2 out of one of my equations. So I just reduced my number of variables in my equations by 1. I do that. So let's just solve this for T2. I'm going to take equation number 3 down here. So I'm going to take this 19,100 equals. So we got our starting velocity times our second time interval, which is going to be t. We had t2 here, but we're going to replace that with 90 minus t1. All right. Plus our initial position we started at. Okay. So now we've got a new equations here with, there's our, we're down to, we have 3 unknowns in that equation. And if we look, I've got, let me just write down my other 2 equations here. I know that vx1 equals 41 t1, and I know that x1 equals 20.5 t1 squared. We can plug that into there, get rid of the x1 to that equation. What about this one? Plug that in right there. If I do that, how many unknowns are left in this equation? I'm down to 1 unknown. So we get 19,100 equals equals, my Vx1 is going to be 41 T1 times 90 minus T1 plus 20.5 T1 squared. Alright? We have one unknown. Solve for T1. Got to distribute first, right? So we distribute 1,100 equals 3,690 T1 squared. If I distribute the second part, I get minus 41 T1 squared. I get plus 20.5 T1 squared. Now I can combine these guys, and I'm also going to move this over to the other side. Alright, so I'm going to get 0 equals negative 20.5 T1 squared plus 3690 T1 and minus 19,100. How do I solve that? Alright, calculate that, see what you got. So open parentheses to start this, use parentheses. These are where you need parentheses for this. You need a double set of parentheses in here. And be careful with that. Of course, that means T2. Look at the equation. You have from up above. T2 is 90. That's T1 equals. Let's just take a look. Hey, got it right. Simple as that, Sam.